Right. Good afternoon, everyone. Hello and welcome. Thank you for joining with us. My name is Richa, your host for this webinar. So today's webinar, we will be focusing on implementing IAC using Pulumi, and we will explore how Pulumi can revolutionize the way we manage and deploy our infrastructure. Also, we will see how different it is from the very well-known IAC tool that is Terraform. And to provide the expert insights, we have Mr. Rohit Sharma and Mr. Pradeep Dasari, who will deep dive into this topic. But before handing over to Tim, let me explain you that throughout the session, if you have any questions, please feel free to type in the chat and we will address them at the end of the Q&A session. So let me request Mr. Rohit to please take over the stage. Rohit, over to you.
Thank you, Richa. So hi, good morning, good evening, everyone. So in this webinar, we are going to talk about IAC tool called Pulumi, and we will see how Pulumi helps application development teams to build cloud-based infrastructure using a language of their choice, and allows infrastructure engineering teams to build scalable and reusable modules that can be leveraged by other teams. Finally, we will go into some live examples showing how to automate IAC tool using Pulumi. This is the brief agenda we are going to cover in this session, and we will talk about Pulumi. What is Pulumi? Then why one can use Pulumi? I mean, what are the benefits and use cases of Pulumi? Then there will be a demo and Q&A session. So let me start with a little bit of background on us. My name is Rohit Sharma. I am joined by my colleague Pradeep Dasari. We both are part of CloudTechner, which is a born in cloud era organization, providing the best of the technology solutions within the space of cloud and automation. So before taking steps towards Pulumi, let me take back to early 2000 or even before 2010, how applications were used to deploy. So anyone can tell how applications were used to deploy in early 2000? Anyone? If anyone knows, then he can answer. Okay. So at that time, developers used to write the code and then build a package into a bundle. And then some from infrastructure team gets this bundle and deploy on the respective servers. So setting up the servers and deploying the applications was a manual process. This involves tasks like configuring hardware, installing operating systems, and deploying the software applications on these servers. The manual process was time consuming, error prone, and did not support the rapid pace of modern software development. Because of that, organizations face several challenges, like need for speed and agility. So as technology evolved, gradually there was a need for speed and agility. Everyone was expecting new features to be released quickly instead of taking months. All were looking into overall operational efficiency to manage the teams better. To meet the peak user load, organizations was looking a quick way of scaling infrastructure and application. And everyone was looking for the quick feedback cycles to fix and deploy the issues or features. So to fulfill these needs, DevOps emerged as a solution. And DevOps emerged as a solution to bridge the gap between development and operations teams. It emphasizes collaboration, automation, and integration of processes to streamline software delivery and infrastructure management. The DevOps movement started sometime between 2007 and 2008, when IT operations and software development communities raised concerns. What they felt was the fatal level of dysfunction in the industry. But still, problem is not resolved in case of infrastructure. While DevOps addressed many challenges in the software development lifecycle, the manual creation and management of infrastructure remained a bottleneck. Imagine a scenario where a development team has successfully embraced the DevOps practices, automating build and deployment pipelines for their web application. They still face the hurdles with the manual infrastructure management. When they need to deploy uh, updates or scale up, they are stuck with the time-consuming, error-prone processes that limit scalability and consistency. So to resolve these issues, infrastructure as a code, or IAC, came into the picture. Okay, now another question. Can anyone tell what is IAC, infrastructure code? Okay, so IAC, or we can say infrastructure as a code, is a managing and provisioning of infrastructure through code instead of through manual processes. Some of the popular IAC tools are Terraform, AWS CloudFormation, Azure ARM templates, Ansible, and there are many more also. But among them, Terraform is the most popular IAC tool. In Terraform, infrastructure is defined with the configuration language, that is HCL, HashiCorp configuration language. But is everything sorted now? Although there are IAC tools. What about engineers who don't know much about IAC tools but familiar with programming languages? Several thoughts will come to their mind. So, what thoughts will come? First of all, another learning curve. So, transitioning to a new tool means investing time and effort into understanding its syntax, principles, and best practices. For instance, Terraform uses its own configuration language, HCL. Developers might initially find themselves grappling with this new syntax, as well as adapting to a different approach to managing infrastructure. And another thing will come in mind, we don't have skills to manage IAC code. So developers might experience a sense of inadequacy when faced with the prospect of learning a new tool, especially if they perceive themselves lacking of the necessary skills. They might worry that their current expertise in languages like Python, Go, JavaScript, etc., is insufficient for the effectively utilizing Terraform or other IAC tools also. This feeling can stem from a fear of falling behind or not being able to meet the expectations placed upon them. So what is the solution? Solution is Pulumi. Pulumi was founded in 2017. Pulumi is an IAC code or infrastructure as a code tool that stands out for its language agnostic approach. It allows users to define and manage cloud infrastructure using familiar programming languages. This versatility enables teams to work with the language they are most comfortable with. Pulumi supports the programming languages like uh, Python, Go, .NET, YAML, TypeScript, JavaScript, and Java. So what is the Pulumi? Pulumi is an infrastructure code tool. So it allows developers to create, deploy, and manage cloud infrastructure using programming languages. Pulumi has fundamentally changed the way DevOps teams approaches the concept of IAC or infrastructure as a code. Pulumi supports multiple cloud providers. So it allows you to deploy any type of cloud infrastructure. You can deploy and manage resources across multiple cloud providers such as AWS, Azure, GCP, etc. And Pulumi uses familiar programming languages. So instead of relying on domain-specific languages, Pulumi enables organizations to use real programming languages to provision cloud-native infrastructure. In other words, you are not forced to learn a new programming language only to manage infrastructure. Now, why one can use Pulumi? First of all, improved operational cost. So by using Pulumi, organizations can improve their operational cost. It is because then organizations don't need to spend money on training the employees for the traditional IAC tools, as they can now provision infrastructure in their familiar programming languages. Increased efficiency. Automation and repeatability lead to faster deployments and updates. Increased efficiency with Pulumi comes from its powerful automation capabilities. It allows developers to define infrastructure using code and automate provisioning and management tasks. Better security. For better security, secrets are encrypted in transit and state file. By encrypting secrets in transit, Pulumi ensures data confidentiality during the communication over the networks, while encrypting the secrets within the state file guards against the unauthorized access even if the file is compromised. And creating DevOps mindset. Traditionally, developers are doing their work, and infrastructure person is working on provisioning the infrastructure. So both are different categories. So by using Pulumi, developers can provision infrastructure, which is creating the DevOps mindset. So these are the we can say benefits of the Pulumi. Now Pulumi projects and stacks. So projects and stacks offers flexibility. It allows you to structure your infrastructure based on your specific needs. And this is similar to how you can organize your code within a Git repository using folders and branches. Now projects. So project is any folder or directory that contains the pulumi.yaml file. It is a project file. And at runtime, the nearest parent folder containing a pulumi.yaml file determines the current project. Now here you can see the typical pulumi.yaml file. So pulumi.yaml file specifies which runtime to use and determines where to look for the program that should be executed during the deployments. Here you can see the runtime in the picture. So supported runtimes are Node.js, Python, .NET, Go, Java, and YAML. Project files also contain metadata about your project. Now here you can see the structure of the Python and Java projects. So first picture, you can see my project. It is the directory, and pulumi.yaml file is the project configuration file. Main.py is the file where the infrastructure code written in Python language, and requirements.txt is the Python dependency file. And second is the JavaScript structure for the project. So my web server is the directory or folder in which the files are there. Pulumi.yaml project configuration file. Main.js is the file where the infrastructure is code written in JavaScript, and package.json is the Node.js project dependencies. So this is the basic structure for the Python is JavaScript for the project. Now stacks. So every Pulumi program is deployed to stack. A stack is an isolated, independently configurable instance of a Pulumi program. So stacks are commonly used to denote different phases of development, such as development, staging, and production. A project can have as many stacks as you need. By default, Pulumi creates a stack when you start a new project. Now, use cases of Pulumi. So, use cases of Pulumi are quite similar as both other IEC tools, like infrastructure provisioning. So, Pulumi simplifies setting up foundational components like virtual machines, networks, and databases using code. It supports multiple cloud providers and abstracts common infrastructure patterns and treats the infrastructure as a code for version control and collaboration. Next one is configuration management. So Pulumi allows managing application configurations, environment-specific settings, and secrets alongside the code. It ensures version controls configuration as a code. It supports the environment-specific configurations and provides built-in secrets management, and also enables the dynamic updates without redeployment. And last but not least is application deployment. So beyond infrastructure, Pulumi automates deploying applications onto the provisioned resources. It integrates seamlessly with the CI/CD pipelines and manages the full life cycle of infrastructure and applications, and also supports the various programming languages for unified development. So as you know, Terraform is the most popular IC tool. Here we can see the comparison between Pulumi and Terraform. So first of all, OSS license, or we can say open source software licenses. So Pulumi has the OSS license, that is Apache license, and Terraform does not have that. It has BSL or business source license. For the language support, Pulumi supports Python, TypeScript, JavaScript, Go, .NET, Java, and YAML, and Terraform supports HCL, as you know. And for state management, by default in Pulumi, state is managed through the Pulumi cloud, and self-managed options are also available. But in Terraform, state is self-managed by default, and managed SaaS offerings is also available there. Now, infrastructure reuse and modularity. So in Pulumi, it is flexible and can use the functions, classes, packages, and Pulumi components. But in Terraform, it is constrained and it can only reuse the Terraform modules. For secrets management, secrets are encrypted in transit and in the state file. And in Terraform, secrets are stored in a separate product, that is Vault. For pricing model, Pulumi is free for individuals, but chargeable for the team, enterprise, and the business critical subscription plans. And in Terraform, it is free for HCP free subscription plans up to 500 resources per month, but chargeable for HCP standard, HCP plus, and enterprise subscription plans. So this is basic difference between we can compare Pulumi and Terraform. Now workflow for the Pulumi. Pulumi program is executed by a language host. Here, main.py is the file where Pulumi program is written in Python. Now, once the Pulumi program is written, it is handed over to the Pulumi engine using the Pulumi CLI, and the CLI serves as the interface between the developer and the Pulumi platform. It provides commands to manage and deploy infrastructure. The engine then compares the desired state of your infrastructure with the state's current state. So based on the comparison between the desired state and the current state, the Pulumi determines the necessary changes required to achieve the desired state. This includes identifying resources that need to be created, updated, or deleted. Now, once the needed changes are identified, the Pulumi engine utilizes resource providers to manage the resources. Resource providers are responsible for interacting with the underlying cloud infrastructure APIs to create, update, and delete resources as needed. So this is overall workflow for the Pulumi. Now, most of the people know about Terraform. Here we can see, we can have a look on the code snippets for both Terraform and Pulumi. So this is the Terraform and Pulumi Python code snippets to create the AWS S3 bucket. Here you can see first picture for the Terraform and second one is the Pulumi Python code to create the S3 bucket. So in Terraform code, there is a resource block which defines the resource, and AWS S3 bucket, it is a type of resource. And example part is the name of the resource. Bucket name is my TF test bucket, and below are the tags. And in Pulumi Python program, first of all, it is importing the Pulumi library and AWS SDK for Pulumi. It creates the S3 bucket with the name my bucket, and the name of the bucket is then exported as bucket name, which will be shown in the Pulumi CLI output after the deployment. So this is the basic difference between the code snippet of Terraform and Pulumi Python code. Now I request to Pradeep to take over for the demo part. Over to you, Pradeep. Thank you.
Yeah, thank you, Rohit. Yeah, that was actually a good explanation. So to add you more on that, so Rohit actually covered how actually Pulumi works and how we can use. So let me clear what exactly how can use the Pulumi with a demonstration. So before directly jumping into the demo, we need something to be get ready in our uh, in our code or in local. So first thing we need to have a one GitHub repository. So while connected to the Pulumi cloud, you need to log in with your GitHub account. And the AWS account, here we mentioned AWS account, but it depends on you. For this demonstration, we are going to use AWS. Depends on you GCP or anything. And obviously a Pulumi account. So I'm going to show you how the Pulumi dashboard looks and the Pulumi CLI in your local. So to run to create resources in cloud. So let me share my screen. So yeah. So when you this is a Pulumi Cloud dashboard actually. So when you log into the Pulumi Cloud, this is how actually it looks. So you can see. So as I mentioned, you can log in with your Pulumi GitHub account. So this is my GitHub account. I logged in, and AWS account. So currently we don't have any buckets and any EC2 instances also. So we are going to show you a demonstration on how let a simple. I'm going to create one simple S3 bucket, and by using advantage of using Pulumi, we're going to create some instances also. So yeah, so this is it. So before this one also, as I said, we need to have a CLI in a in a local. So I already have it in my local. So if I type Pulumi, so it will going to give me what are the commands you can run by using the Pulumi. So yeah, so now you have Pulumi cloud account, you connected with your GitHub account, and you have AWS account also. So to get started with using AWS and Pulumi, you need to configure your CLI, your local with your account. You have to connect with that. For that, generally people you run AWS configure. So I already done that. So by using access key and secret access key. So that my keys are there. So now you connected to AWS account also. So first thing you need to do is first you have to connect to Pulumi Cloud. So how you going to connect that? You need to run Pulumi login. It will show you already I connected with my Pulumi Cloud. So before that, let me show you how actually you can connect. Let me log out. So I'm logged in or logged out from my Pulumi Cloud. Let me log in back, and I will show you what exactly it's doing in the backend. So you see, it's gave me an error like there is a when you run Pulumi login, it actually checks for a token, seek access token. So if you see there is no access token in my local, so that's why it is giving you're not able to log in. So I already have my token here. So how you actually going to generate this one? Let me show you that. So when you go log into the Pulumi cloud in this button, so here personal access token. So yeah, you just need to create token and that's it. It will give you one code. Then you need to export that in your local. The moment when you export and Pulumi login, it will connect. See, it is checking the access token. If it is there, it is connected. If it is not there, it is not connected. So now you have you connected your local with the Pulumi cloud. First thing first, as Rohit mentioned, there is something called project. So we need to create one directory. Directory is nothing but a project. It will act as a project. So what I'm going to do is I'm going to create one project, one directory for my project. So let's say my first project. So I created my first project. Let me go into it. See, currently you see we don't have any files in it. Okay. Now, first step when you after creating the project, you need to run a command called follow me. What this command telling you is it going to create some virtual resources and requirement whatever the requirement files are should be there for this project. It will going to create in the backend. You're going to see that files also. I'm going to explain each one of those that file. So what this command telling is we are going to create one new project with in AWS by using Python programming language. So yeah, so we are going to use Python and AWS in this demonstration. So the moment when I hit, it will going to download some virtual environments in the backend and the dependencies all which are required to this particular project. So while this happening, I'm going to show you the commands which we're going to use. I'm going to use some of these only, but I'm going to explain what exactly what command is. So this command already we know the Pulumi login logout command and the access token, and this is a Pulumi new to get started. You create your virtual environment in the backend. And by default, when you create the Pulumi, when you run this command, it actually create one virtual environment, as I said. But it actually create one stack also. Stack is nothing but as we compare with Terraform, stack is nothing but a state file you can call. So by default, when you run this, it actually creates a dev stack. You see here creating a dev stack, here it's showing. So, but let's say you don't want to the dev stack. Let's say I want staging stack. Like I want a beta, I want a production. So you can mention explicitly that. So hyphen stack, whatever the stack name, and you can also list the stack with the by with Pulumi stack ls. And you wanted to, let's say you created it and you wanted to delete it. You can mention that Pulumi stack rm command remove, and I'm going to talk about these also. So we are going to use Pulumi preview. Pulumi preview is nothing but you wrote a code and you wanted to see what resources it's going to create. I don't wanted to directly apply that, but I wanted to confirm these are the resources the code actually going to create. So you need to Pulumi preview, and the Pulumi up. Pulumi up is nothing but the Terraform apply kind. So when you run Pulumi up, it will going to apply your changes into your cloud, and the destroy is something which deletes everything in from the server. And the Pulumi up hyphen fn skip is something when you run the Pulumi up command, it actually previews first. These are the resources it's going to be create, and then it will going to install your resources, launch your resources. To skip that, let's say I know I don't want to see what it's going to create. I already know the code and it's going to create these resources. So you can use this command to skip that preview part, and at the same time destroy also. You can use this. And let's see. See, as I mentioned, when you run that, it's going to create some dependencies and virtual environment. Generally take 1.5 2 minutes maybe. So let's wait. So the moment when we hit that up command, it directly creates one project in your Pulumi dashboard. And as I mentioned, by default, it creates a dev stack. So this is the stack, and this is the project name. So yeah, if you see, so it is completed. Now the moment it completed, it says you need to run. You can run Pulumi up command to create your resources. So we are not going to do that now, but let me explain you what it exactly have. If I list this, so you have so many files. Let me explain each file. So yeah, so virtual environment directory, and this main.py. The main.py, it have a main. It is a main file where you actually write your entire code to create resources. So by default, when you create a new project, it will give you a sample code to create a S3 bucket. So it's saying like it will going to create a bucket called my bucket, and it generally is going to have some extra string in it. But as in your bucket is a bucket name should be a globally different, so that's why it will going to add one that extra string. And at the end, it will going to show you the bucket name when you applying your code. And the dev pulumi.dev.yaml. So pulumi.dev, it actually stores a stack related information. So you can mention your variables kind of uh, thing in here. Like you can see this is the region we are going to deploy anything in your cloud. Now the pulumi.yaml. Pulumi.yaml, it actually if you know Helm charts, it actually act as a chart.yaml. So where it actually stores everything related to your project. So it will going to show, it will going to have a content called what is your project and what runtime you're going to use. In this, we are going to use Python, and where you actually installing your infrastructure. So AWS Python is it's telling you like you're going to create your instances in launch your resources in AWS with Python. And at the end, that requirements, it actually Pulumi and the Pulumi AWS. So yeah, now you have your files, you wrote your code. Now how you can run this? So I'm not going to run this because I already have uh, separate code for this. So this is a by default code you can see when you start with your first project. So now let me go back and show you one more thing. So yeah, so this is a code I'm going to run this in this demonstration. So what exactly this code is telling is, so we are going to create one S3 bucket and security groups. In that security group, three policies, three rules actually, two ingress rules and one egress rules. And at the end, we are going to use for loop conditions. So that's the main thing by using the main difference compared to Terraform. Using the programming language, you can write conditions, loops, for condition for loops here. So this is the code we are going to use. So what I'm doing is I'm going to call all my variables from variables underscore dev file. So this is the file where I stored my everything, the bucket name, my EC2 instance AMI and instance name, and the security group name, and what are the CIDR block I'm going to allow. So this is a simple bucket it's going to create, and the bucket name it will going to show at the end, and the security group, egress, ingress, and here I'm not going to create one simple EC2 instance. I'm going to show you how you can use conditions here to create multiple instances at the same time. So instance name, if you see, I gave two instances name. So it depends on you. Let's say you wanted to create only single instance. You can put one single instance name. I mentioned two, so it will going to create two instances. So I'm calling it in a loop here. So this is the code. EC2 instance and AMI, everything is calling from here. And at the end, it will going to show us the public IP of that particular instances, two instances. So before going to directly apply, let's see how you can write this code in Terraform as we comparing with Terraform only. So let's see. So, so this is a sample code to create S3 bucket in Terraform. So what it going to do is it will going to create an S3 bucket with with the bucket name of my hyphen tf and some tags it will going to add. And in the same way, let's say you wanted to create multiple instances in your by using Terraform. How you going to do that? So you can directly give the count here, but here like variables we are using. So by using a variable also you can do. So what depends on the count, it will going to create that many instances by using Terraform. So in our case, we are going to use Pulumi Python. So it will going to create two instances. So as I mentioned, so you have your code. Now let's say what it's going to create, how many resources it's going to be create. For that, as I mentioned, there is a command called Pulumi preview. So let me run it. So it will checking the dev stack. It will going to give us how many resources will be going to create. Before that, I will going to show you. Let's see, we don't have any buckets. And EC2 instances running. Currently, you see we don't have any running instances. So yeah, it's saying 8 resources, which includes like S3 bucket, secret security groups, two instances, and it actually includes a dev stack also. So now let me do pulling me up. Come on, pulling me up hyphen yes. It will take directly. It will go into directly apply. So as I mentioned in this commands list, you can skip this preview. So as I mentioned, it will when you run Pulumi up, it will going to preview first. What are the resources it will going to create? So you already saw that with the Pulumi preview command. Now you don't want to see that. So you can skip that with hyphen fn skip preview. So let's see. Is there any resources are created? Still no. Yeah. So the bucket is created as we mentioned here in variables file webinar demo test bucket one. So it is created just now. So yeah, two instances created called web1 and web2. And one more interesting part in Pulumi is now everybody is moving to AI generation, AI tools. So Pulumi itself going to have its own AI tool. So you can directly use that Pulumi AI. So Pulumi AI we have. So whatever the language you have, so you can select and directly ask. So it will going to give you the code. And to get started with Pulumi actually have a document where you just simply follow this, and you will going to understand each and every step. So it actually a simple and strong document. You can just simply go through this in this blog. You just need to just click, and it will going to give you everything to create a simple S3 bucket and so hosting a static website. So yeah, so this is completed. Now you can see S3 bucket and EC2 instances. I'm not going to do SSH into the EC2 instances that we already know, but I'm going to show you the destroy command, how destroy works. In destroy also, it will going to show you what are the resources it will going to destroy. So that's why this command we can use to skip the preview. Let's see in console. See, it's shutting down. The resources are going down. So yeah, this is it from the demonstration part. Rohit have some stuff to say. So yeah, Rohit, over to you.
Thank you, Pradeep. So I'm resharing my screen. Let me know when my screen is visible.
Yeah, Rohit, we can see.
Okay. So now, what are the challenges? We have talked about the benefits of Pulumi. Now, what are the challenges with the Pulumi? So, first of all, deviation from standard IAC practice. So, while using general purpose programming languages provides the flexibility, it also means Pulumi deviates from the declarative standard set by the tools like Terraform. This deviation could create challenges for the teams migrating from Terraform or other similar tools. Now, managed service dependency. So Pulumi requires a managed service for the state management. While this provides scalability, it also introduces an increased dependency and potential latency issues and imperative and declarative models. So Pulumi, with its use of imperative languages, can lead to complex configurations, especially in large-scale projects. Those used to declarative models like Terraform's HCL might find Pulumi's model less intuitive. And last but not the least, essential account creation. So in Pulumi, by default, state file is stored in Pulumi Cloud. So before start using Pulumi, first we need a Pulumi account, Pulumi Cloud account. But in Terraform, by default, state file is stored locally. So before start using Terraform, you don't need to create a Terraform Cloud account. If you want to store the state file in the cloud, Terraform Cloud, then you need to create a Terraform Cloud account. So in conclusion, we can say that Pulumi offers a modern approach to infrastructure management, combining the power of programming languages with the flexibility of cloud infrastructure. And by adopting Pulumi, organizations can achieve greater efficiency, scalability, and consistency in managing their hybrid cloud resources. So this is all about Pulumi. Now I request Richa to take over. Over to you, Richa.
Thank you so much, Rohit. That was a valuable information. All right, let's open the floor for the Q&A session. If you have any questions, you can unmute yourself and ask or type in the chat and our presenter will answer it.